Welcome back to the video lecture series for Introduction to GIS. Today what we're going to talk about, or what we're going to do, is kind of the first activity or first lesson that actually deals with modeling. So we're going to be using some tools from the ArcGIS toolbox, and we're going to use that to basically do what is called a suitability analysis. So today's lab will be looking at different parameters that would make a place ideal for a wind farm, and we'll look at all the individual parameters. We'll query them out, use tools such as clip, dissolve, and erase. We'll overlay these different parameters and try to identify a location that would be the most suitable for a wind farm in Colorado. So up until now, we've kind of done some basic queries, run some very simple tools, learned about select by location and select by attribute. We know how to manipulate tables and run statistics. Now what we're going to do is put that all together and actually run a model and do a simple spatial analysis, which is specifically a suitability analysis. So to start today's lab, I want you to go log into D2L, click on the Labs folder, and I want you to download the data for Lab 7. Notice how it's called Wind Colorado Zip. And then I also want you to download the Lab 7 worksheet. Now what I'm going to suggest you do is make a new folder in your documents called Lab 7. And save your PDF in that folder. And then remember, every time we download a zip file, we have to extract it or unzip it. So you'll want to extract all files from your Wind Colorado zip. And again, I'd recommend you put that in your Lab 7 folder that you just created in your documents. Okay, great. Now, before I do anything, I'd just like to explore, see what's in that folder, and it looks like we have a .gdb file, which, remember, is a file geodatabase, and we also have a map document that comes pre-populated with the data we need, so that's nice as well. So I'm going to close all this down, and we're going to go look at this PDF to see exactly what it is we need to do. All right, so for this particular exercise, we're going to imagine that we've been hired as consultants to work for the State Colorado Office of Renewable Energy. And what they want us to do is to identify the places that are most suitable for planning new wind energy farms in Colorado. And they've identified a couple parameters that we need to meet. So the first one is that they want there to be enough wind, which is going to be modeled through wind power class to produce energy. They want it to be no further than 5 miles from a highway, because maintenance crews need to be able to easily access the wind turbines. It also has to be no more than 50 miles from a city of at least 25,000 people. It cannot be on federal land, and if all of those criteria are met, the site needs to be at least 1 square kilometer in size. So we can see there's several different kind of parameters that require different analysis techniques. So we'll be doing attribute queries, we'll be doing buffers, we'll be doing a combination of buffers with queries, and then we'll also be doing some geometry calculations to identify the area of these places. So as I mentioned, all this data is stored in a file geodatabase, and so what we're going to do to get started is we're going to open the Wind Colorado map document. So we'll go ahead and minimize this lab activity, and we'll open up ArcMap with a new blank empty map, And then in our catalog, we're going to browse to our Lab 7 folder that we made. And we're going to go into our Wind Colorado folder. And here we can see we have Wind Colorado Geodatabase with several different files. And we also have a map document. So to start, let's drag this map document over here to open it. Okay, great. Now, if anyone happens to get a red exclamation mark over here, that would indicate that you either forgot to extract or unzip your data, or your paths are broken. And you can click on the red exclamation mark, which will prompt a dialog box similar to this, where you can set the data source. And what you'll need to do is navigate to the missing files and set them, and that will correct all of the red exclamation marks within your table of contents. Okay, so here we can see we got a cities layer, a continental divide layer, highways, rivers, counties, wind, and a few other things. So we have a bunch of data that we'll be using for this exercise. And so to start, what we're going to do is explore the data a little bit. And so in the list of the 8 map layers that we see, you can see that there's one called rivers. And what we want to do is turn on the rivers layer, and you need to try and identify what the 4 most important rivers are in Colorado. Now this is a little tough because it really involves exploring the table, the attribute table, and coming up with some justified reason as to why these are the most important. So for the sake of this demonstration, I'm going to hypothesize that the most important rivers are actually the longest ones. So we're going to go through the process of trying to query out the most important rivers. So I'm going to turn off cities, and I'm also going to turn off highways. And, you know, that looks good, so that I can just see the rivers and maybe the counties. And there are surprisingly a lot of rivers in Colorado, but what we want to do is figure out which ones are the longest. And so the first thing I'm going to do is open my attribute table and explore what's in here. And we can see we have a name that identifies the name of the river. And we can also see that we have shape length, which if we reference down here, we can see that we're in meters. And if we looked at the coordinate system of rivers, we could also identify that we're in a Lambert conformal conic projection that is in fact using meters as the linear measurement. So here we have shape length, which would be in meters. And so I want the longest ones. So what I'm going to do is sort this field descending, so that the largest rivers are at the top. And we can see here we have Pond Creek. We can highlight that, and we can look at it, right? Look at it on the map. One thing I want you to notice is that the highlighted features are actually yellow in this map document. Now this is something that was previously set in the selection properties. I don't particularly like yellow, so I'm going to go to selection and hit selection options and turn it back to cyan, because that's my preferred selection color, which happens to match the attribute table. Okay, so we see here that the longest river is something called Pond Creek, and we can see on here where that is, but to me that's not entirely convincing. So I'm going to go down here and look at the Apishapa River, and we can see where that is as well. And while it's long, I don't feel like it's the longest river. And the reason for that is I know that there happens to be a river called the Colorado River, and I'm quite surprised that it's actually not showing up in the top of the list. Something must be going on. So if we scroll down through here, let's see, or maybe we sort this by name so we can find the Colorado rivers. There we go. We can see that there's actually many different Colorado rivers. So, you know, maybe this should raise some curiosity. So why don't we click on that and zoom to that Colorado River, And we can see what's happening is that the river is broken up into individual segments. And we're actually only getting the shape length of that segment. So what that means is that those other rivers that showed up had the longest individual segments, but they might not be the most important, or in this case, the longest rivers. So what I'm going to do is I'm going to try to summarize this table based on P name, so I can see the total length of all of the different river segments with the same name. So I'm going to right click on shape length, and I'm going to summarize the table. Actually, I'm going to right click on P name and summarize that field. And what I want is shape length, and I want to get the sum of all of the segments with the same name. So I'll hit OK, and it's going to add a new table to my map. I can scroll down here and open the table, and we can see what it did is it ran that summarize based on my selected feature. So sometimes it's nice to only summarize a selection, but that's not going to do what we want. So we're going to go back to the rivers table and clear our selected features, and we'll re-summarize that with the sum. And we'll make a new table, add that to the map. Go ahead and open that. Okay, great. Now we can see we have everything grouped together. So we have the name of a particular creek or river and the total, or the sum, of all its segments. Okay, so now what we can see is we have some interesting things. We got this creek or river called A, that's the longest. Well, what's going on there? So we can highlight all of the A's, or what we'll do is we'll actually go to our rivers table, and we'll find A, and we'll click on a couple so that they're highlighted on the map, and we can see that there are many different A's, which are actually generic names given to small tributaries or creeks. So those aren't going to work for the sake of this exercise. So we'll go back to our sum table, and we'll sort this based on descending, so that the highest is at the top, and we can see that we have Beaver Creek, Arkansas River, South Platte River, and look at that. That's exactly what I wanted, the Colorado River. So what we'll need to do is we'll need to query these out from the rivers table. So we'll go back to the rivers table, and we'll click the table properties and go to select by attributes. First one I'm going to do, and I'm going to actually reference my sum output table, is we're going to want P name equals, and we're going to get unique values, and we're going to find Beaver Creek. And what I'm going to actually do is just type it in. I know it's a string field, so I'll use a single quote and type in Beaver CR, and I'll end my single quote, or single quote. Hit apply, and now let's reference the map. It looks like we ran into the same problem that we had earlier with the A's, is that there are many different Beaver Creeks in Colorado, so that one is obviously not one of the longest rivers. So we'll go back to our attribute table, and we'll see that the next one that looks to be not like a major river, I know what the Arkansas River, South Platte, and Colorado River are, so I'm not worried about those being more than one river, so we'll go down to Sand Creek. And I'll again do a query on Sand Creek, and I'll hit apply. And again, we have more than one Sand Creek, so maybe creeks are not appropriate for longest rivers. So we'll jump down the list, and we see that we have the Yampa. And if you remember from an earlier exercise, the Yampa was one of those rivers where the peregrine falcons were nesting. So it looks like we have the Yampa, the Colorado, the South Platte, and the Arkansas River. So we'll go in and we'll construct a query to select all those out. So we'll type in Arkansas River in my single quote, And we'll need to build a complex query, and in this case we'll use OR because a river can't be have more than one name. So I'll say OR pname equals single quote Colorado River in single quote. We'll hit Oregon pname equals South Platte River, or see what I got, Arkansas, Colorado, South Platte, or pname equals single quote Yampa River. Okay, now we'll hit apply, and it looks like I've run into a problem. So let's see, what did I do? I said pname equals Arkansas River, or pname equals Colorado River, or, and look what I've done. I've forgotten the single quote in front of the South Platte River. So I add that, I hit apply, and we'll go look at our rivers table and look at only the selected rivers. And hopefully we have Arkansas, Colorado, South Platte, and Yampa. So we've got the four longest rivers now, and we can look at them highlighted on the map. What we'll want to do is turn this into a new selection by going right-clicking on the rivers, going to Selection, and Create Layer from Selected Features. Now I can turn my rivers layer off, and there I have the four longest rivers. In Colorado, which I would justify as being the most important, maybe you could turn on your cities layer, and you can see that one of those rivers goes through a major city, which would again make it important. And you could even go in and turn on labels so that we can see the name of these rivers. And what I'm going to do is go in to the properties and change the actual label color to blue, which I think is more appropriate. Wrong one. What just happened? Oh dear. Let's see. Well, that's weird. Let me remove that and create another layer. Did something weird. Create layer, turn off rivers, make it blue. There we go, and bump it up in size. And label. Well, we'll maybe just leave it like that. Okay, so what I want you to do is I want you to turn this into an actual map in the layout view. I want you to export that map as a JPEG, and then I want you to embed that map into a Word document. So all of our answers for this need to be typed in a Word document. So you make a new Word document, and you'll go in and you'll put question 1. You'll insert that map as a picture, and then you will answer why you thought or came to that conclusion. The next thing I want you to do is to explore the data and answer questions 2 through 6. And again, put your answers into that Word document. Some of these answers require you do a little bit of outside research on the web. Then we get down into the actual modeling component where we extract the parameters. So remember what the first criterion was. We wanted to identify an area where the wind power class is at least 4. So, so there has to be some data that contains information relating to wind power class. And if we go in to ArcGIS, and we look down here, we actually have a wind layer. So I'm going to turn off my rivers, and I'm going to turn off my cities. And I'll go in and I'll turn on my wind layer. And so here we have, let's see, we'll have to check. It looks like vector data. We can identify this by going to source, and we can see that this is a polygon, which means it's a vector type. And we have some colors that represent the different wind power class. So what this tells me is that there must be a field called wind power class, and if there is, we can actually query that field out. So if we look here, we can see that there's definitely an area that's blue where there's higher wind power class values. So immediately I'm kind of envisioning that this wind farm will be contained somewhere here in the Rockies, maybe even on the Front Range. We can identify where the Front Range is by kind of turning on this continental divide, and everything to the east of the continental divide is considered to be the Front Range. Okay, so I'll turn that off. Go back here, and what we'll do is we'll construct an attribute query on the wind layer. So we'll click on Table Properties, go to Select by Attributes, and if we re-reference this, it says where wind power class is at least. So that means it could be 4 or anything more than 4. Okay, got to be careful about English language in queries. So we'll say WPC is greater than or equal to get unique values 4. We'll hit the apply button, and look, it's highlighted all the areas where it's over 4. So now I have to do something with this selection. Remember, there's 2 ways to manage selections. Here, they tell you to export the selected feature. You can do that, or I'll do a quicker step, and I will right-click on Wind, go to Selections, and hit Create Layer from Selected Features. And then I'll make sure to name that so I know what it is. So here in the lab, it says to name it Wind Acceptable. So I'll go minimize this, go over here, and turn selection to acceptable. Okay, great. So now I can turn off my wind layer, and if I turn on only wind acceptable, you can see these are all the areas that met that one criterion, right? Okay, so now we'll move on. The second was to make sure that they're no further than 5 miles from a highway. So there's a couple ways we could do this, but to me it seems like the easiest way might be to do a buffer that is around highways. So we have a 5-mile buffer zone around a highway representing all the places that that are easily accessed by maintenance crews. So what I'll do is I'll go to geoprocessing and I'll run the buffer tool. I will drag over highways. And it's creating a highways buffer layer. It's trying to put this in my default geodatabase. For this particular exercise, I'm okay with that, but you might want to put it in your Wind Colorado geodatabase. So we want it to be 5 miles. And then we're going to do something a little bit different here, where we're going to use a dissolve option, where we're going to want to dissolve all of the buffers. So what happens when you run a buffer operation is it does a buffer on each individual segment. And if you have lots of segments, you could have thousands and thousands of buffers. If you have all those buffers, it takes the other operations we run in this lab much longer. It takes a lot more time. So make sure that you put the dissolve type to all. So I'll click OK. And then we should get 1 buffer around all of the highways in Colorado. It's taking a long time. You can actually go to geoprocessing in results, and that will pop up a new window showing you what operations are running. So I can see here that there's an hourglass, meaning that the buffer operation is still running. So we'll wait for that to finish before we move on. Okay. Now what we can do here is go back. Oh, there it did. It just finished. Okay, so good. So we have 1 buffer representing all of the areas that are 5 miles from a highway. And we confirm that it's 1 buffer by going to our attribute table and seeing that we have a single feature in that feature class. Okay, great. So what I'm going to do is I'm going to change this to the name Highways Acceptable, just so I remember what these layers are. So great. So we have two of our 4 criteria, and what we're doing is we're looking for a place where all of these things occur or happen. So we can immediately see that, you know, this area kind of around Boulder is looking very promising. We can turn that off. See, there's acceptable wind there. We can turn it on. See, it's within 5 miles of a highway. So now what we'll do is we'll move on and try to find cities or areas that are 50 miles from a city or no further than 50, right? So it could be 50 but no more. So that might be less than or equal to, right? And then we want it to be a city containing at least 25,000 people. So the first thing that we're going to do is try to identify the cities with at least 25,000 people. So to do that, we'll go to our cities layer, and we'll turn some of these other layers off. We'll get rid of our results session, and we'll right-click and we'll explore the cities table. And if you reference the instructions, they tell you to use a field called Pop 100. So what we can do is we can sort this with the biggest ones at the top. And we can see that there are some that are over 25,000, so we're in luck. So, so let's go ahead and do an attribute query where Pop 100 is greater than or equal to. We'll hit get unique values. It turns out it's a number field, so we can type in 25,000. And we do not need to use a comma. We'll hit apply, and look, it's highlighted all the records that meet that criterion. So what we'll do is we'll turn this again into a new layer, and I'll call it cities acceptable. Okay, great. Now we have 3. Well, not quite 3, to be honest. And I'm going to call this not cities acceptable, but cities over 25K. Because if you remember, we're looking for an area that is no further than 50 miles from those. So what we actually need to do is run another buffer tool using those queried out cities. So we'll drag those over. We'll put in 50. Change it to miles. And we'll again want to make sure that the dissolve type is set to all because we want one big buffer. Hit OK. And there we go. We got all the land that's no further than 50 miles from cities that are over 25,000 people. So I can go ahead now and remove this point layer, and I'll call this layer cities acceptable. Oop. There we go. City acceptable. All right. So there's 3 of our criteria. Go back to the document, and we'll see that we want it to be not on federal land. Okay, so there has to be a field that contains these codes, and it looks like it's probably the AGBR code, right? And so which one is not federal land? Well, it looks like anything without a code or that is empty. Notice how there's 2 quotes with nothing in them. That means it's empty. Is not on federal land. So all these are federal land. Anything with no code or empty is not. So what we'll do is we'll go in here and we'll look at this layer called federal land. We'll turn off some of our other stuff, and we can see that we got these different colors that represent the different areas that are owned by different federal organizations. But one thing that's kind of odd is it looks like there's some data missing. And we can see that this field, or this color, is the no code color. So I'll change it to a different color because it's hollow or white, and it's a little misleading. So I turn it on, and let's see. Other is an interesting color too, so I'm going to make that one rose. And this one, we'll make that blue. So now I can easily distinguish between different types of federal lands, and I can see that some stuff is missing. So this all must be owned privately, and sometimes data isn't complete, but we can see that everything in green or where there is nothing is privately held and not federal land. Okay. So there's a couple steps involved in getting the right answer for this one. So let's see, we'll scroll down a little bit, and I'm going to kind of jump around here for a second. Well, actually, we'll go back up. So we've visually identified places that are not on federal land, but because of the structure of the data, we're going to have to use a few different steps to get to the right answer. So what I want you to do is to combine the data for, let's see, it's going to be criteria 1, 2, and 3. So what we're going to want to do is we're going to want to run a tool called the intersect tool. Now the intersect tool looks for the overlap of multiple different features. And so we right now have 3 of our criteria selected out. We know what the 4th is, but we haven't yet done it. So, so what we'll do is we'll run an intersect tool on the first criteria, and then we'll run a different tool for the 4th one. So we're going to go into ArcMap, and we're going to go to Geoprocessing, and I want you to select intersect. And as you can see here, it takes 2 or more inputs and shows you the places where both of those inputs occur or happen on the surface of the Earth, right? So these 2 are overlapping. The overlapping sections are what is produced in the output. So what we'll do is we'll drag over cities acceptable, highways acceptable, and wind acceptable. And we'll hit the OK button. And I'll go ahead and turn off my federal lands layer for the moment. And look, what we've got is an output where all 3 of those layers occurred at the same time. But notice it looks a little bit crazy, right? Things are going nuts. There's all sorts of different polygons because different things are intersecting different lines. Every time there's an intersection, we get a line. But that's okay, right? We'll fix that. So one thing you could do is you could look at the area in those acceptable places by summarizing the square kilometers field. But for now, let's pay attention to the 4th criteria, because we've got to make sure that these places are not on federal land. So what we're going to use is a different geoprocessing tool called the erase tool. This works, it's like the opposite of the clip tool. And what it's going to do is, if we can select all the places that are federal lands, we can erase that from our results. And so the only stuff left over would be the places that are not federal lands. And the reason we're going to use the erase tool is because we do have some holes in that layer that we need to be aware of. And so because there are those holes, the erase tool will do what we need. So what I'm going to do is I'm going to go in and run an attribute query on federal lands, and I'm going to select all of the places that are not federal land. So I'll open the attribute table, I'll explore the AgBur field, and where there's nothing, that means it's not federal land. So we'll run an attribute query, we'll use AgBur, where it equals get unique values, and we'll use the no code. I'll hit apply, and now it's selected all the places that are not federal land. But to use the erase tool, I need to select all the places that are federal land, right? And so you could have done this through a longer query where you said, hey, AgBur equals BLM, BOR, DOD, FS, and so on. But instead, we're going to switch the selection. So you can right-click on federal lands, go to selection, and hit switch selection. And so now it's selected the opposite of what we just did. And we'll turn this again into a new layer. I'll turn off federal lands, and I'm going to call this, well, it's fine, federal lands selection, right? Did that work right? Yeah, okay. So all this stuff in blue is federal lands, and we're going to use that in the erase tool to erase the federal lands from our city buffer intersection that we ran, right? The intersection of all 3. So I'm going to actually call this all 3 intersect. So to get the erase tool, we'll go to the toolbox, and we'll go down to analysis tools, and under overlay, there are some different overlay tools. Notice how intersect is in the overlay toolbox, but it's also in the geoprocessing menu bar. Same tool, just a different place. Okay, so we'll open up the erase tool, and we're going to see what this does is it takes an input, it takes an erase feature, and it erases the erase feature from the input. That's what the output is. So in this case, the input is going to be our all three intersect, and what we're going to want to do is erase federal lands from it so that the remaining is all of the places that had our first three criteria minus the spots that are federal lands. And so this will meet our fourth criterion, right? Okay, so our input is going to be all three intersect. Our erase feature will be federal lands selection. I'll hit OK. And I'll turn off federal lands. I'll turn off all three intersect. And now we have a reduced area where all four of our criteria have been met. So I'm going to go in here, and I'm just going to rename that for this all four, right? Okay, great. So we're coming along really good. But again, we have these funny looking polygons, and we know that we have a criteria that deals with square kilometers, and we can see down here that we're in meters, and over here we have square meters. It's not in kilometers, but there's only four features, and if I click one of those features, it highlights a really big area, and something just doesn't look right. So we've got to do a few more kind of processing steps to clean up our data. All right, so we've run the erase tool. We've got all four criteria done. We talk about how we got these goofy looking polygons, but we know we have this area component for the fifth criteria. So geez, what do we do? Well, there's a tool called the multi-part to single part tool, which basically takes multi-part features that we see now and turns them into a single part. So we take many feature classes and we turn them into one, and then basically we dissolve that so that we can aggregate polygons that are touching each other into one big polygon. And so we'll look at that process here in a second. So what I want you to do is to go into your search option, and in search I want you to type in multi-part, and that will search for the multi-part to single part tool. You could also find it in the toolbox if you wanted to by going to data management, and I believe it's features and multi-part to single part. But the search option works really well. So multi-part to single part, and we'll add in all four of our criteria, and I'll call this all four single. Okay, we'll hit OK, and it's only going to work on my selection, so make sure you clear your selected features before you do that. And I'll rerun the tool. Okay. Okay, so you might be saying, hey, look, it doesn't look any different. What just happened? But if we look at the attribute table, there's a lot more records in here. So what it did is it took every single one of these polygons and it turned them into an individual feature. So this polygon is now a feature, that one is, that one, and so on. Whereas on the previous layer, they were all one common feature, even though they didn't touch each other. Okay, so this is good. So but the problem is all these little polygons make up one continuous tract of land, and obviously if we were putting a wind farm on there, we wouldn't pick this one polygon. We would probably go for this whole area because it's all acceptable. So another interesting tool that we can run, or useful tool, is the dissolve tool. This takes multi-part features that are touching each other and turns them into one common feature. So here everything that's in green and touching each other turns into a single feature. So I'll drag in my all four selection single part, and we're not going to pick a dissolve field because we want to dissolve all of them, and we'll just click OK. And now you can see that all of my polygons that we're touching have been merged into one big polygon. But if we look at the attribute table, we only have one polygon. So it's all now one big, giant linked feature. So we're part of the way there, but we're not the entire way there. So if we go back here into the attribute table, it says to make sure that you did not check create multi-part features. So you got to make sure you read these instructions really closely, otherwise you'll get the wrong output. So what I'll do is I'll remove that, and we'll rerun the dissolve tool, where I drag in my all selections layer again, and there's something that we need to check. And oh, look, this right here, create multi-part features optional. We'll uncheck that, right? And we'll click OK. And now we'll go in and look at this attribute table and look. Okay, so now if the polygons are touching, they're one feature, right? Whereas before they were all, even if they weren't touching, one feature. So now we have, see, that's great, what we need. Okay. Okay, so now we'll go back to the lab, and we've run the dissolve. We unchecked create multi-part features. We explored the attribute table. We could identify how many rows are in there, and so now we got to think, okay, we want to make sure that there's at least 1 square kilometer in land, but we know that our area calculation is in square meters, and so 1 square kilometer is 1 million square meters in size. So we need to select these areas. So we'll go into ArcMap, and we'll run an attribute query on the shape area field of our dissolved all four selection layer. So I'll hit the drop down arrow, go to select by attributes, where shape area equals, we'll hit get unique values, identify it's a number field because there's no single quotes, and we'll type in 1 million. So that's 0, 0, 0, 0, 0, 0. 6 zeros. I hit apply. Uh-oh. Let's see what just happened. Sort this. Descending. That one's over. Let's see, 2, 0, 0, 1. So what have I done? 1, 2, 3. Oh, I have one too many zeros. So we have 1, 0, 2, 3, 4, 5, 6. Okay, great. So I'll hit the apply button, and why am I still not getting, am I on the wrong table? No, we're good. Shape area equals 1. Oh, I've made a mistake. We want it to be greater than or equal to. So now I'll hit the apply button, and okay, great. We got 411 records that are over 1 million. Although I'm still, did I make a, let's see, 1, 2, I'm going to put in commas. My eyesight, sometimes fails me. 1, 2, 3. Oh, and look what I've done. I've actually only done 100,000, so I'll delete that comma, and I'll go back, and I'll put in another 0. Now it's actually a million. Sometimes people make mistakes. It's good to know how to work through it. And now instead I've got 90 places, and I can scroll down here to see where, or we'll go to my selected features, scroll down, and we see, let's see, that we stop at 1,092,000. And so I could actually sort my shape area field descendingly, and we can look and see that we did not pick up the 995,000 one. So that's good. That worked correctly. And what I want to do is again turn this into its own layer, and I'll give it a better name, saying that the 5th criteria has been met, and I can turn off some of this other stuff, and what should be resulting is only polygons that meet all 5 of our criteria. The thing is, there's a lot of them, right? It's quite crazy. They're all over the place. So let's see, what could we do here? We look in here, it says, well, we want you to rank all of the final areas so that there's not quite so many. And one potential way to rank these polygons is to identify which one is the windiest site. That could give us some more detailed information. So you'll notice that the wind power class field has been lost through the dissolve. However, if you look back to what you were supposed to have called S part, you will see that the wind power class field is in there, and we can actually bring it back by performing a spatial join between those layers. And what spatial joins do is they link attribute information to layers that are that overlap. So if something is occurring on one spot on the Earth in one layer, we have another layer, and we want to somehow get that info into the other layer, we can run this thing called a spatial join. It's not similar to a table join, but it's accessed through the same spot. So let's go up here, and we'll figure out what layer was supposedly called S part. For that matter, I'll just look here. Let's see, all 3 intersect, open, wind power class. Well, basically what I want to do here is I want to figure out the average amount of wind in the entire polygon. And so what I can really do is go back to my wind layer, and I can join from my wind layer, right? So what I'll do is I'll go to, let's see, I'll right click on 5th criteria. I'll go to joins and relates. I will hit the join button. I want to do a spatial join attributes based on a spatial location. And let's see, I want to get the, average wind power class. So I'm going to click here on wind and go to wind power class, or wind. And each polygon will be given a summary. So I want the average amount of wind. So I'll hit OK. And we'll go and turn our other stuff off. Notice how we got an output that looks almost identical to the 5th criteria. But if we go into the attribute table, the difference is that now we have an average WPC field, right, where it tells us the average amount of wind in that area. And so we can go in here and we can sort this descendingly, and we can identify places that have the highest average, right? So this one, which is 5, might be the most, or it has the highest amount of wind, but it's not the biggest spot, right? There are ones that are bigger. So we could actually go down here to this big tract of land, and we could highlight that. And if we look at our selected features, that has an average wind power class of 4. And you could kind of explore the data a little bit to look at, which ones are the biggest, and also maybe which ones have the most amount of wind across the entire area. So here we could look at this giant tract of land, and we open the attribute table, and that's got an average wind power class of 4.5. But maybe the difference between that one and the other one we looked at is that it's a little bit farther away from a major city. So there's a little bit of personal or human interpretation here. You have to figure out which ones out of that list of places that meet all of our criteria is the best, or which couple are the best. And so if we go back to our document, and we scroll down here, I basically ask you to try and identify the 3 that you consider to be the best. And what I want you to do is to create a map or multiple maps that shows the top 3 sites. So which ones are the best? Why do you think that? And I want you to export those maps as images and to embed them into the lab sheet, right? So what you'll do is you'll answer all of these questions, and when I ask you to embed maps, you'll insert that in our Word document. So if we were on 16, right, it would be question 16 right here, and you would have a map that you've embedded into the Word document. Okay, make sure to include all your essential map elements: title, north arrow, legend, scale bar, source. Otherwise, I deduct points. Right, make your legend look good. Minimize white space. Think about the production. You're a consultant here, so you're trying to tell a story and convince people to do something. So then we'll move down to 17. I want you to kind of summarize in a paragraph what you've learned from this. Talk about the different tools you've run, maybe how you could use this in different types of applications. And then lastly, I want you to make a PDF that is the top choice for your wind farm. So the number 1 spot. And make sure that you are a good cartographer, okay? Now in this particular exercise, I actually offer an extra credit opportunity. I'll give you 1 point out of 10 or 10% more points if you create a KML that is your top site. So for here, we'll just go ahead and imagine that I've picked this spot for whatever reason as my top site, and I'm going to turn this again into its own layer, and I'm going to call this my top site. Okay, and I'm going to make this red because red is very easy to see. Okay, so that's my number 1 spot, and maybe I want to be really creative, and I want to show our clients this site's location in Google Earth. Well, there's a really nice tool in ArcGIS Toolbox that converts a layer or a feature into a KML. And so if I go over here into Conversion Tools, you can see that there is a to KML option. And if you want some more detail on how to do this conversion, you can reference your book, and if you go to page 153, there's actually a lesson that talks about how to convert data into a KML. So this is a very useful trick. Okay, so we want to convert a layer to a KML file. So we'll go top site, pull it in as a layer, and look, it's going to create this thing. It's got a funny name, so we'll call this windfarm.kml, right? And we'll go ahead and use the clamped feature to ground option, and we'll not choose a layer output scale, and all the other defaults are fine. So I'll click OK. And then the next thing I'm going to do is I'm going to fire up Google Earth, right? So we'll just do a quick search. There's Google Earth. Click on that. And then using Windows Explorer, I'm going to go to my documents in ArcGIS, which is where the file went, and I'm going to look for windfarm.kmz. And look, there it is. So to get this into Google Earth, all I have to do, go back to ArcGIS, is double click on this KMZ file, which it's trying to load in Adobe Photoshop, which is incorrect, right? So instead, I'll just simply drag the KMZ over into Google Earth. That's another way to do it, right? Okay, so now we have exactly what we saw in ArcMap in Google Earth. A great way to present information, right? You could even go in here and you could go to your options and you could turn on terrain. Let's see, show terrain, and we could get a 3-dimensional view of our site, right? It's pretty neat. And so now, if you're giving a PowerPoint or you're in some sort of interactive discussion, you can show people really what this site looks like, what the terrain is. Maybe it's too mountainous and you wouldn't want to go with it, or maybe it's fine, but you could even explore your top 3 sites as KMLs and use the info that you had in Google Earth with the terrain on to make a more informed or better decision. So that's really all we have for this lab activity. We've gone through a lot of stuff. This is what we would call a suitability analysis, and we've taken a giant leap where we've left the basic query and panning and zooming kind of world, and we've gone into an analysis environment. So it's very powerful, and this could be done for a variety of different applications. It could be for a Walmart, it could be for solar farms, it could be for vineyards. The list really goes on and on, but the overlay analysis is one of the truly powerful things you can do with the GIS and also spatial information. So we'll go ahead and stop there for today, and tune in tomorrow for another modeling lesson that deals with slope, aspect, and DEM information. Thanks.